Welcome everybody, and thank you for joining our Geomagic Freeform Product Spotlight series. This webinar is focused on shell-cut clay and 2D slicing in Geomagic Freeform. I appreciate you joining us today, and I hope you'll be able to join us on future Product Spotlight webinars as well. A few housekeeping items before we get started. As you may have noticed, all attendees' lines were muted upon joining the webinar. Therefore, please use the Q&A button on your screen to submit any questions as we go along. In an effort to abide by our 20-minute time allotment, we will not address questions live during the webinar. However, we will follow up with you after the webinar with an answer to your question. Additionally, we will make the answers to all frequently asked questions available for all of you who have attended. Finally, in a couple of days, you'll be receiving a follow-up email with a link to view the recording of this webinar, as well as a sample file that can be used to trial the process being demonstrated today. Once again, thank you for joining us today, and now I will pass it on to Dave DePinto, a Geomagic Application Engineer, as he will be leading today's demonstration. Dave, it's all yours.
Thank you for that warm introduction. Welcome to the Tuesday Product Spotlight Freeform Plus Shellcut and 2D Slicer webinar. My name's Dave. I'm going to take you through an overview of Shellcut and the 2D Slicer tool over the next 20-ish minutes. So let's get started. What is the Shellcut tool? The definition provided by the Freeform help is that the Shellcut tool creates a new piece from the intersection of projected sketch profile and a shell of the active piece with a defined thickness and offset. That is a mouthful and a brainful. As you can see from the diagram next to us, that we have a 2D sketch, a shell, a wire cut, offset. These are all of the components of what this tool does in order to produce its result. My next slide shows you a little bit better of a picture of what's practically happening. If you look on the right, you'll see we start with a sphere, and you can do an offset on it. Everyone who's using Freeform should be somewhat familiar with offsetting, and then you take that offset piece and you create a shell from it. Okay, so far so good. Now, using a 2D sketch, you can trim away everything that's outside, leaving just the area that's inside that profile of the offset piece that has been shelled. There's a lot of practical applications for this tool. It's immensely powerful, and I will show you some great ways of using it. The 2D Slicer tool is very straightforward. It slices, it dices, and it's an interactive cross-section inspection and visualization tool. What that really means for you is you have an interactive, fast, responsive tool that will allow you to look inside your parts and look for tolerances, look for overlapping areas, look for voids, as well as the ability to extract bitmap images. So you could take a slice image of an object, you can extract 3D curves, you can extract 2D curves, and then use those in your workflow for reverse engineering or for design. So this tool here is very powerful for two different distinct workflows. We've all seen that Freeform is great for assistive braces and devices, and this here is our pal Derby. We helped Derby out several years ago with making some prosthetics to help lift him up because his front paws were not fully developed as a puppy. So we were able to create a brace from a scan of a cast of his front legs, a lot for padding, build everything we needed to off of it, and we didn't have Shellcut at that point. Going back and revisiting this, I was able to shave off more than half of the time in design that was required to do this because of all of the manual individual steps and keeping track of the thicknesses of the various shells. This was huge. And you can see for documentation purposes, I have some some 2D slicer images on the side. So we have the 3D render and the 2D slices from something using Shellcut. Fantastic. This here is our forensics workflow. You would begin with a base skull. You would be able to offset from the surface in a very quick and accurate way in order to rough out and build up the clay in order to sculpt the face, in order to hopefully eventually make a composite that could be used for identification. This here was another time saver for us because this is a proven workflow that has been done in Freeform in the past, typically with selection, offsetting, or simply adding clay, tugging and pulling, and doing a variety of other sculpting techniques. Going back with Shellcut, I was able to make this a lot more streamlined and easier to teach and more user-friendly. So, moving on, I'm going to give a quick demonstration. So we will move over to Freeform. And we have a shoe last. So this here is the internal structure of a foot that has been prepared for creating a shoe design. Those in the shoe design industry will probably laugh and scoff at my inarticulation of the correct terms, so I'm going to try to keep this very simple so I don't expose my lack of knowledge here. Looking at this from the side, we're going to begin with creating a 2D plane. As you can see, that was the base for using Shellcut. So now I'm going to sketch on that plane, and I'm going to build what is going to be the beginnings of the sole for a high-performance type of minimalist running shoe that will pay very close attention to the contours and not provide a lot of extra padding and support, especially at the beginning of this design. So I will choose my curve point tool, and I'm paying attention to the curve that is tracing around the lower part of the last, and then I get very, very wild and crazy and sloppy with the other part of my curve. This does not matter because with Shellcut, we are doing an offset and a trim. So everything that's inside this area that is past where this is offsetting does not matter. When I go into Construct, I will choose Shellcut and pick my profile. Since we have this piece right here, I will offset this at about 5 millimeters. Actually, no, I'm going to create a piece that's about 5 millimeters thick, and I'm going to have this not offset completely from the surface. I want this to be slightly inside the surface so I can Boolean remove the shoe. So I'm going to do a 4 millimeter offset. So this will create a part that is 4 millimeters off the surface while still allowing me to have a little bit of room to trim from the last. Using volumetric offset, I will set this to 0.5 millimeter and click Apply. And there we go. We have something that was trimmed to that angle, offset from the shoe, or offset from the last rather, and follows the contour. So from here, if I turn around, look at the bottom of my new sole, go into Sketch, I can start creating details and adding to this using Shellcut and creating a whole bunch of pieces of geometry very quickly. So for instance, if I'm going to create something up here at the toe, I'm going to pretty closely trace this edge right here and come down the other side. I wanted to make several sections here, so I'm going to cross the toe and I will cross it again so I can create two separate sections. And using the trim tool, I clean out in between. So now I have two different areas of the toe. With Shellcut, right now I have my choice of either offsetting from the sole or going back and offsetting from the last. But for this case right here, since these are going to be smaller tread type of details, I'm going to offset from the sole itself. So I will select both of these, do this at about 2 millimeters, and I'm going to offset this by 1 millimeter. Click Apply, and now I have two distinct regions. Actually, you can see that right now I built through to the back, so if I undo and turn on front only, I should be able to. Well, there was a little bit of a gap here because of how the thin wall right there, so I would just have to manually trim that if we hide, you can see that because my sketch here went all the way around to the edge of the shoe, or the edge of the sole, that it came up, but that's easy enough to trim away. This is the perils of doing a live demonstration. But part of the power of being able to do this with shell cut gives me individual shells, individual pieces of clay or mesh, because I can do these offsets as mesh. And from here, I could texture these, do independent work on these, and keep them resolution independent for speed until I want to combine them all together. And if I want sharp transitions, I could convert them to mesh first and get very sharp lines at the intersection, which would not be possible in a traditional all clay embossing and other type of detailing workflow. So this gives us a lot of power. I am actually going to clean this up a little bit, so I will go back to my front plane, look from the side, and create a very quick sketch just to simply remove that area that I accidentally created. So remove that. There we go. So I'll hide that. And now, using the 2D slicer, I go into my analysis tools. I have my little 2D slicer meat cleaver right here. Right now you can see that I have this set to shown pieces. So I'm going to turn this on active piece first and just inspect what the last looks like. So you can see that right now I am holding down the button for the stylus and I am able to look at the interior of the last. Likewise, if I enable the sole, I get a preview of the sole and as well the shell cut region. I can turn on all shown pieces and you can see how these all play together. Let me re-enable the sole. And this is all done with the haptic device, so you can see that down on the bottom I have the tread detail, I have the sole shown and the last. They're all intersecting each other, so when I go to remove and clean those out, I will have a perfect tight fit. The other nice thing that can be done with the shell cut, if I go in here and go back to sketch and simply add a detail here on the sole. If I choose shell cut and no offset, so set this to 0, so it's going to be flush with the surface, and I'll make this 1 millimeter thick. Actually, I have to make this 2 millimeters thick because of the resolution of my piece. When you're doing shell cuts, because you're doing offsets, you have to abide by certain rules in order to make the tool actually work. Because voxels have to have a minimum thickness in order to exist, we impose a 4 times resolution on the thickness compared to the clay resolution you're working with. So I'm going to very quickly create a small star here in the sole. So this here is the sole, so I'm going to rename this very quickly, and I'm going to remove the star from the sole. So it is a very fast workflow for creating inlays. So especially at higher clay resolution that I'm working at for demonstration, if I were to create this, you would see that I have a perfect fitting piece that is flush with the surface, follows all of the surface contours and any other texture that may have been on the surface, and gives me the ability to choose a thickness, and then after the fact, of course, I can do the removal and create a pocket for my piece. This is great for printing workflows. This is great for even machining. When you're going to do multiple passes, you would be able to cut out your pocket and then have your additional pieces later. And since I have a little bit of time, I wanted to do something fun. So, if you have ever looked online and come across something called squirrel armor, I suggest Googling it. The images are fantastic, but there are people who do very silly things, and one of them is actually create armor for squirrels. So, I'm going to take all of this. I'm going to create my squirrel from a curve sphere network. If you want more information on curve spheres, how to create them, how to work with them, please add comments, let us know. This is a potential for another webinar for Freeform. And now change my coarseness to about 0.5 millimeter. And I already have a sketch which will provide me a rough base for adding a little bit of detail to this squirrel. So going into shell cut, I'm going to select what will be the helmet. Move on to my next piece. I will do 2 millimeters, offset by 2 millimeters, so it sits directly on top of the existing model without a gap. Turn off front only, click apply. Actually, undo. Change my coarseness to 1/4 millimeter, so we get some sharp edges. And now reactivate my squirrel, move on to my next sketch, and apply with the same settings. Repeat these for the overlapping pieces that go down the squirrel's neck. And now, as you can see, if I take my tug tool and hide my sketch plane, make this a bit larger, and I will just tuck these under so there is a little bit of overlap. Pull up the outside edge. You can see that pretty quickly you can create a whole bunch of pieces that are referenced off of an existing piece, combine them together, and of course you have a battle-ready squirrel. So I thought that was fun and something kind of a little tongue-in-cheek and a little fun to show at the end of the demonstration. So if you have any questions about software, applications, solutions, please go to 3dsystems.com. Sales information and pricing, we have the email right there. Or if you want to download trials and or get technical support, please visit gettingstarted.geomagic.com. Thank you very much for attending this webinar, and I hope you found it both entertaining and instructive. All right, back to you.
Thanks, Dave. This brings us to the end of our Geomagic Product Spotlight webinar on shell cut, clay, and 2D slicing in Geomagic Freeform. Please be on the lookout for invitations to future Freeform product spotlights from 3D Systems. In the coming days, each of you will receive an email with a link to the recorded version of this webinar, some useful links regarding Freeform, as well as answers to frequently asked questions. If you asked a specific question during the webinar, we will be sure to follow up with you with an answer to your question in a timely manner. Thank you again for joining us, and have a good rest of your day.